you guys totally have them down, so looking great. Well done. Okay. Yeah.
For the future, can you slow down a little?
Right, and that's.
I'm just flying through it.
You mean when I'm talking, or the information?
Probably both.
Right. So the talking I can't do anything about. Right. So that was, I don't know if I talked to you guys about that. That's kind of one of the problems with me is I kind of have this thing where I talk fast. It's just kind of how I am. So that's kind of, I can try to change it for like 5 minutes, and then I'm right back. You know, it's unfortunate. I'm sorry. And I'm trying to do this. We're actually a little bit behind where we were before. So I think I am keeping as good of a pace as I can without, you know, I mean, part of it is there's a lot in this class. So I'm cutting out as much as we can. I'll try to give as much time as I can. But yeah, thanks. How about that? So it seems like you guys are okay with that, like I said. The other question is, are these two the same, or are they possibly different from each other? So that's the question. So looking at these two numbers, same numbers, different numbers, what are they? Yeah, so they could be the same, right? Or they could possibly be different. So I don't know if you guys noticed this one over here, but I kind of put these numbers in over here, right? If something was 14.17, it would round to 14.2. This looks like it's to the nearest tenth. This is 14.2, right? And it could be exactly on 14.2. I don't know for sure. That's the problem. It could be 14.24. It could be 14.20. It could be 14.17. It could be any one of these or other numbers as well. So it's hard to tell whether these two are the same or not. I know this is true exactly to 2 decimal places. Right? I know this is absolutely true to 2 decimal places. That's accurate. But this one's only accurate to 1. So these two might be different, or they might be the same. Because this could be 14.7, 0.17, or 14.24. This gets into what we call kind of precision and accuracy. So it is it has to do with you know, we're going to get into a lot of things like as far as what we call significant digits and decimal places. The more decimal places you have, the more accuracy. You know, it's good to this amount. So it's not a big deal, but yeah, it'll come up here and there. So I kind of want you guys to be aware that these two things are not necessarily the same. This one's more precise, more accurate than this one is. Next, we're going to talk about levels of measurement. Let me get someone to read this one. So how about Constantine? Go ahead.
Just all of them?
Yeah.
Normal, categorical names.
Oh, wait, the whole thing. Read everything on there.
All right. Just nominal categories, name, color, gender, and years. Ordinal, nominal plus, can be rank, order, birth, order, finish, raise, letter, grade. Interval, ordinal plus, intervals are consistent, true zeros. Ratio, interval plus, ratios are consistent, true zero. Below which no values exist, gallons, age, height.
Great. So you have to give an example to share with your partner. That's okay. But just to kind of go through those again, nominal, those are things that they don't have an order to them. They're just categorical, like colors, right? Blue is not ranked higher than red or green or other things like that. Jersey numbers, again, those are just labels. Right? There isn't any sort of ranking to them. So nominal is just the labels, basic categorical labels. Ordinal qualifies for everything that's nominal, but it also can be ranked. So in other words, pizzas, right? Small, medium is larger than a small, a large is larger than a medium. So they have an order to them. Letter grades have an order to them, A, B, C, D, F. Phase of the race, first, second, third. Those have an order. Those are ordinal. They're also technically nominal, right? Because they satisfy those requirements as well. Interval satisfies all requirements of ordinal and nominal, but also the intervals are consistent. However, there's no true zero. So in other words, degrees Fahrenheit, the difference between 1 degree and 2 degrees Fahrenheit is the same as between 81 degrees and 82 degrees Fahrenheit. There's the same amount of energy involved in raising that temperature. Ratio is everything, interval and everything before. However, also the ratios are consistent, which means that there is a true zero. Zero really means none at all. So let me talk a little bit more about that interval part and the ratio part because people get confused. So interval, the amount of heat to increase from 30 degrees Fahrenheit to 60 degrees Fahrenheit is the same amount of heat, increase in heat from 70 degrees Fahrenheit to 100 degrees Fahrenheit. So that's the same amount in terms of heat. So that's what makes it interval. However, for example, say I'm running a race, right? First place guy comes in, second place guy comes in right after him. Third place guy is way over here. Those are not equal intervals. This one, distance from here to here is not the same as the distance from here to here. So same thing with grades, right? So someone could have an A and someone else could have a B way over here, or someone could have an A and someone could have a B right here. There's this range of A's and a range of B's that are not, it's not fixed, if that makes any sense. So that's why the grades are not interval. They have an order. An A is definitely higher than a B, but an A can be anywhere along here, and a B can be anywhere along here. Whereas with 70 degrees Fahrenheit, it's right here, only right there, nowhere else. Ratio is similar, except for it has zero really means none at all, right? So, for example, temperature, interval 7 degrees Fahrenheit. Fahrenheit is interval, but it's not ratio because 0 degrees Fahrenheit does not mean no temperature. You can have, it's 0 does not mean 0 degrees Fahrenheit does not mean no temperature at all. Now, kelvins, if you guys are familiar with kelvins, 0 degrees Kelvin does really mean no temperature at all. So kelvins would be ratio. Also money. Think about money. The ratio of $5 to $10, is $10 twice as much as $5? Yes, it's ratio. Because zero amount of money really means I have no money in my pocket. I got nothing. Right? If I'm talking about the 0th minute, that means there is no time has elapsed at all. 0 minutes means 0 time at all, which means that 20 minutes really is twice as long as 10 minutes. If I do the ratio of 20 over 10, that's 2. 20 minutes really is twice as much as 10 minutes. It's ratio. Don't worry about those too much. They're not super important. You're going to get one homework problem on them. They're not going to be on the exam, but I do need to cover it. So we're going to cover it in class a little bit so you guys can do the homework problems on this, okay? So go ahead and figure out what measurement level these are all at. So go ahead and hop out to your Jamboards and go ahead and do them there, discuss them in the group and do them. Just take a couple minutes, hopefully, to do that. Let me go and start recording again. All right, so perfect. All right, so let's go ahead and go through this one. So hair color, it's not ranked, right? Zip code also not ranked. So one zip code isn't higher ranked than another zip code. Letter grade, that is ranked. There is an order, but they're not the same. Like I talked about before, the difference between even within A, if A has a range within it, automatically it can't possibly be interval. ACT score, yep, that is interval because the difference between getting a 45 and a 42 is the same as between getting a 42 and a 39. It's there. Every point, has the same sort of weight to it there. But you can't get a 0 on the ACT score. A 0 on the ACT score doesn't mean no score at all. Like no score at all, you still get some points for that of some sort. Ratio is for height, because height, if you have no height, that really means you are really, if you're 0 height, really means you have no height at all. You're right there flat. And then age, if your age is 0, that really means you have no age at all. You were just born, right? So that's why age is ratio, because 0 really means none, really is 0. And then temperature degrees Fahrenheit, we talked about that earlier. That's interval, because 0 degrees Fahrenheit does not mean no temperature at all. All right, questions?
The difference between birth order and age. So like on your notes it says birth order.
I don't know. I don't have birth order. My board says birth order?
No, on our notes, when you give the example.
Oh, birth order. Birth order. Birth order is, are you the firstborn, the secondborn, or the thirdborn? That's ordinal.
Okay.
Yeah.
Okay.
Yeah.
Got it.
So yeah, birth order is which child are you? Basically.
So, age be like ordinal, or I mean, because like
Age is how old are you down to the nearest fraction of a second?
And there's 2 0.
Yeah, and there's a 2 0. So if you are 0 years old, that means you were just born right this second. Right then.
and this code is nominal, right? Not ordinal.
It's nominal. Yeah, because I am 94566. The school is 94551. So because I end in 66 and school ends in 51, is my zip code better than the zip code here? Is it higher ranked than the zip code here just because it has a higher number? No. Yeah. But having an A is definitely better than having a B, for sure, 100%. It's ranked. I guess you could argue that being 90 years old is not better than being 25 years old. I don't know, but it is definitely, it means more. So I should phrase it that way. Okay. Yeah, go ahead.
Just like to clarify, for ordinal, is that like ranking it based on how favorable or least favorable it is?
Or it just means there is an order. There's an order. You can put them in order. This one goes here, this one goes there, and you can't mix them up. Like you can't go small, large, medium. You know what I'm saying? And you can't go first, then fourth, then third. They have an order. There's an order to them. Yeah.
I have a question.
Yeah.
So just to clarify, height and age are both intervals?
No, height and age are both a ratio. Why is my screen not shared? There you go. I'm sorry. I'm sorry.
Because you said ratio, right? So it has a 2 0.
Yes. So, in other words, 0 means none at all. If you have a height of 0, that means that there is no height at all. 0 height. It has no height. It'd be flat.
Temperature would be interval, right?
What would be?
Temperature?
Temperature Fahrenheit is an interval, because 0 degrees Fahrenheit does not mean no temperature at all.
Okay, thank you.
You're welcome. How important is this? Not very, guys. It's like I said, you're going to have a homework question on it, and that's it. Don't sweat a lot of time on that one. Okay? So this is more important, somewhat more important. Sampling techniques. So let's go with Elizabeth B. Go ahead and read the first one for us.
Random method generation. All members of the population have an equal chance of being selected.
Yep. So this is kind of the best option, random, when everything has an equal chance of being selected. Nolan E., go ahead and read us the next one, systematic, and the rest of the bottom part. Yeah, he's super quiet.
Sorry, my mic muted.
Okay.
You want me to read the...
Starting from this part here.
Okay. Systematic, every case subject.
Mm-hmm.
Sample obtained by picking every 20th customer starting randomly with a number from 1 to 20, so 3, 23, 43, 63, etc. Right,
perfect, thank you. All right, so systematic means you're going to pick every 20th or every 30th or every 10th or every 100th, right? It's a system. Because, you want to take just the first 5 people walking in the door because they could be all in the same family, and then you have a lot of overlap. You don't get a good sample. Next one, stratified sky S. Go ahead. This part right here.
Stratified, divide into nominal groups. It is to survey M40 students, divide into classes, and randomly pick 3 from each class.
Perfect, thank you. Right, so stratified means that you take some from every group. You divide them into groups. They don't have to be the same amount for every group. For example, I could split it into students, teachers, and administrators. And maybe I take 100 students randomly and only 10 teachers randomly and only 1 administrator randomly because there's more students and kind of less administrators. But every group gets represented. So that's the stratified, where you pick a certain amount from each group to make sure every group has representation. Cluster, how about Malia? This part we get right here.
Use only randomly selected groups. To survey all California community college students, randomly pick 10 colleges and randomly survey students there.
Right. This e.g. means in other words, or for example, I think is what it means. For example. So say I want to survey all I pick community college students. I randomly pick 10 community colleges because it's way too hard to go all over California and randomly pick amongst all 114 community colleges. So I just kind of say, okay, I'll randomly pick these 10. I'll grab 100 people from each of those colleges. It just keeps things a little bit easier. So you pick 10 clusters to pick from, and you kind of grab a cluster from each of those spots. And then convenience is when you survey a convenient group. For example, I go to a mall to get teenagers because it's convenient. There's lots of them there. And then last is self-selected, right, where you only use those who volunteer to respond. Why are these two and kind of part of that one, light blue? Why don't you take just a second to ponder, maybe 30 seconds to ponder on your own, and then I'll just ask for volunteers. Why do you think? Any ideas? Any guesses?
They can be biased.
Yeah, totally biased, right? Self-selected is totally, it could be biased because if I go to a mall, I'm not getting any kids who are in after-school sports or doing clubs or other things like that. Convenience can be totally biased because, that's convenient, sorry. Self-selected sample is biased because it's people who want to answer. So typically, if you're looking at reviews of things, what you're going to get are the people who are really, really happy, or the people who have a personal stake in it, like, they own the company, or you're going to get people who are really, really pissed off. So you're going to get a lot of those, a lot of, like, the people who are mad and the people who are, maybe have some sort of ulterior motive. And the people who like it, usually just like, they don't bother reviewing it. Everything's fine. Why would you, even take note, right? So that's why self-selected sample is often biased. Cluster can be biased if you take too few clusters. If you don't take enough clusters, like say I want to know about community college students and I only sample 3 community colleges out of 114, I could get a very bad, I could end up with 3 colleges who are all pretty similar and get just a really bad sample. That's not very representative. All right, and then here, this is also on your notes. You don't have to write anything for it, but it's just on there. So sampling error, that is just random error, unavoidable error. So sampling error is kind of not really good error, but it's error you can't help. So in other words, if I randomly picked 5 students out of our class over and over and over again, eventually I would get all male. 5 students, and my sample would be all male. Is it safe to assume that our class is all male? No, it's just randomly you're going to get some unusual samples. That's what sampling error is. It's an unusual sample just due to randomness, and that's just going to happen. A non-sampling error is avoidable. That's because it's any other error. Like you got bad data, someone lied to you, gave you a bad response, you mismeasured you mismeasured something, you used a bad sampling technique, things like that. Biased sample, that's non-sampling error. You could also have some errors because of small samples. So how about Carla? Carla V.
Maybe small samples?
Yeah.
Okay, conclusions should not be based on samples that are far too small. Small rural countries have smallest kidney cancer rate and
Keep going.
non-response occurs when someone either refuses to respond to a survey question or is unavailable. People who refuse to practice
Pollsters.
have a view of the world around them that is
Markedly different?
markedly different than those who will let pollsters prevail.
Perfect, thank you. Right, so small samples is actually super interesting. I read this really cool book, and one of the things it was talking about was how small samples are really tough. So they had this cancer study, and they found out how much cancer was in different counties, and they found that this rural county in the southern states, and it was mostly Republican, they had the smallest incidence of a certain kind of cancer. So they're like, oh my gosh, maybe it's like the clean living out there, and people at rural counties are good. Maybe it has something to do with them being conservative, maybe religion. Maybe in the South, I don't know. And so they're having all these different sort of theories about that. And then someone pointed out that the highest incidence of this same cancer was also in a small county, rural, in the South, Republican. And the bottom line is that when you have a small group of people, it's very easy to get a small group of people to be unusual, right? To have a large number of them or a small number of them doing something. If you only have 500 people, it's really easy for 500 people it's easier for 500 people to all be one thing or another thing, versus if you have 1 million people, it's a lot harder for 1 million people to be all one thing or another thing. So that's the thing with small samples. And that's why small samples are more likely to be incorrect, right? Because it's easier to have them accidentally or randomly be all one thing or another. This is super, super interesting as well. Gavin, go ahead and read for us.
A classic example of undercoverage is the Literary Digest voter survey, which predicted that Alfred Landon would beat Franklin Roosevelt in the 1936 presidential election. That survey sample suffered from non-response from low-income voters who tended to be Democrats. How did this happen? The survey relied on a convenience sample mailed out to people from telephone directories and car registration points. In 1936, people who owned cars and telephones simply weren't asked.
Absolutely.
It was a voluntary sample. People could choose whether to mail in their response.
Perfect, thank you. Right, so that's a big deal. They run this huge story saying Alfred Landon's going to win the election, blah, 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 landslide, whatever. And what happened was they didn't ask everybody. They took a very, very bad sample. It was a convenience sample. They only picked people who owned telephones and they're like, telephone directories. That's a great place to find people and for mailings. Car registration lists, another great way to find people to mail stuff to. And those people just, they were wealthier. So, they got this horrible sample selection because of that. Totally useless. And who's ever heard of the Literary Digest? Nobody. Why? Because they totally screwed this up. Right? So, you make a huge mistake like that and you end up paying for it. So let's go ahead and take a break now. It is 6:23. We'll start back at 6:24. So go ahead and just take a 10-minute break.